Good day, everyone. In this video, I will present and discuss the proof of some known results on Lebesgue's outer measure. So, actually, this is a continuation of our previous video. Now, let's have here proposition 1.5. We have this statement. Now, before I'm going to prove proposition 1.5, let me have a brief recall on the concept of set and infimum. So here, recall that if x is in A and then we show that x is in B, we mean here A is a subset or equal to B. Follow? Or if A is a subset or equal to B, we have this statement. They are equivalent statements. And also, for the infimum, if we let A be a subset of B, and then the infimum is medyo opposite ang value. So we have here the infimum. This means that the infimum, or let's have small, infimum of B is smaller than the infimum of, A. Now, why is this so? Now, let's try to consider here the real number line. So, since A is smaller, we have here, and say we have here set B, the bigger set, the infimum of A is here, somewhere here. This is the infimum of A. And then for the infimum of B is somewhere here. When we say infimum, it is, could be the smaller or equal to the value of the set. So here, this is the infimum. Then this is the infimum of B. As you notice, the infimum of B is smaller than the infimum of A. So that's why we have this. So I guess we're now ready to prove proposition 1.5. Now in proposition 1.5, we have this statement. If A is a subset of B, then the Lebesgue outer measure of A is less than or equal to the Lebesgue outer measure of B. As you can see here, this property is what we call the monotonicity property. So first, we let the family of open covers of A and B. So we let here, let this is A and script B be the, actually this is the family, or these are the family. So family of open covers. So family of open covers, this is script A is the family of open covers of A. Script B is the family of open covers of B. Recall that when we say open covers, they are the collections of open intervals. Say for example, this collection here, IN, this collection covers A. So if this collection covers A, we can say that A is a subset of the union of the interval, where I sub n, where n is from 1 to infinity. This is the collection of open covers. So open covers of A. Now take note, see, script A is the family of open covers. Therefore, this script A, this set rather collection belongs to the family of open covers. Hence, this family of open covers of A is equal to the set of the collection of open covers. So it is the set of the set. And take note, this collection here, the members of this collection are all open intervals. Follow? And B also follows. And to further illustrate the concept of the family of open covers, let me have an illustration here. So please take note of this. I will erase this. So by the way, if we have this one, so script A and script B are the family of open covers. Sa kanisa A, this is for B. So we have here open covers of A. We have this notation. And since this is the open cover of A, this belongs to script A. Okay, family man siya of open covers. So again, this is the our script A, the family of open covers of A. So let's have an illustration. Okay, for our illustration, say we have here ito, real number line. Take note that if we have, say for example, we have here set A, and our B is bigger than our set. So for the covering, open covers, we have this one, and so on. And we can have any open intervals there as our illustration. So if, as you notice in our illustration here, if we get the collection of open intervals, say for example, this is in script B. Script B, family of open covers. So muna yung mga members. Kung open cover man daw ni siya, when you say open cover, it means B, that is, so we have here B is a subset of the union of I sub n. Now if we get, as you notice here, if we get the collection of intervals here, any intervals here, open intervals, it would also cover A, right? Because A is just a subset of our set B. So again, if we get here the collection of open intervals as our I sub n here, that covers B, it would also cover A. Follow? Because A is smaller than B. So in that case, we have the statement, if this collection is in script B, then this collection is also in script A. So this collection also covers A, rather. It covers A. Now in that case, we have here our if-then statement. If this collection is in the family of open covers of B, then this collection is in the family of open covers of A. In that case, we can say that script B, the family of open covers of B, is contained or subset of script A. So that's it. Now we are going to let the set, the collection of the summation of the length of our open covers. Say we have here, we let here, say we let S sub 1 be equal to the set of the summation of the length of I sub n. Actually, we let this one because we will be using this one to obtain the Lebesgue outer measure of A. So because in our definition, we need to get the summation of the length of I sub n, where this collection covers the set. So such that, and this collection is in script B here. And another one, we let S sub 2 be equal to this set. I sub n, such that this I sub n here is in the family of open covers of A. So script A. So we have, okay, by the way, do not forget this one, ha. Script B is a subset of script A, the family of open covers of A. So now in this case, since script B is smaller than script A, so we can say that S1 is a subset of S2. Follow? Because this family of open covers of B is smaller than the family of open covers of A. So we have this one. Now in we know that actually if a set is a subset of another set, we know that ang infimum is just the other way, just like what I have said a while ago. So the infimum of S2 is smaller than the infimum of S1. That's it. Hence, of course, S2 here is equal to the summation. So it means we have the infimum of the summation. Hence, this is equal to the outer measure of A or B. See, S2 is here, ang collection of open covers is in the family of open covers of A. So this is the outer measure, Lebesgue outer measure of A. And then this is also equal to the Lebesgue outer measure of B. So S1 is from the family of open covers of B. So we're done. We have shown that the Lebesgue outer measure of A is less than or equal to the Lebesgue outer measure of B. Now, in our next proposition, we let A sub n, where n is a natural number, be any collection of subsets of R. Then, we have this inequality. Now, I will not discuss anymore the proof of this one. I will just only discuss the concept of this proposition. Actually, the concept of this is most likely the same as getting the length of the intervals. Okay, let us try to consider. Let me have this as our illustration. Say, for example, we have a 1, and consider 2 sets lang. Okay, as our illustration. Say, for example, this set is a 1, and say, overlapping set siya. Yeah, because in our assumption, wala siya gibutang if disjoint or not. So, any set, it could be overlapping or non-overlapping set. So, we have here A, and then A1, say this is our A sub 2. Now, as you can see, if we are going to get the length or the measure of the union of A sub 1 here, or A sub n, if for all na to, where n is from 1 to infinity. If you're going to get the length of the union is just like that, just a shorter length compared to the sum of the length or the measure of, actually we have here the Lebesgue outer measure of A sub n, where n is from 1 to infinity. So as you can see, if we're just to get the length of, or the outer Lebesgue outer measure of this set, it is longer sa length ani, right? So therefore, it is less than or equal. This is the union. We're getting the Lebesgue outer measure, and then we have here the sum of the Lebesgue outer measure of each set. So it is, the length is, kumbaga kung the length is longer than this one. So we have this inequality. So that's all. My next video is a continuation of the discussion of some known results on Lebesgue outer measure.